We wanted to provide an update of our activities in 2017. Margaux holds a large land package in southern British Columbia. And up until now, we've been referring to those properties by individual names based on historical work that was done or various purchase agreements that we have. But there's becoming too many names, and that's causing some confusion with folks that haven't been to site and aren't as familiar with the area. So to simplify our message, going forward when we talk about our exploration, we'll refer to only two projects, the Sheep Creek Gold District and the Kootenay Arc Lead Zinc District. Our land package hasn't changed. In fact, it continues to grow as we consolidate claims and fill in missing gaps. All that's changed is the way we'll be speaking of these. So all our gold projects are now lumped together under the umbrella of the Sheep Creek Gold District, and all our base metal projects under the Kootenay Arc Lead Zinc District. The consolidation of this area has been our focus for the past year, and we've been able to effectively tie up a large area that has about 800,000 ounces of historical gold production, as well as significant historical lead, zinc, and tungsten production. This is a complex geological area, and before I talk about the details of our work in 2017, I want to recap why this is such a well-mineralized area and why we've focused on this particular district. So first of all, there are some very large, very deep faults that cut through the area. These are what's known as transverse basement faults. And what's significant about them is that they're crustal scale features. In mineral deposits, fluid pathways are critical. So these faults that tap into the deeper, hotter part of the earth act as good conduits for mineralizing fluids. Many of the big mineral districts around the world are associated with this type of structure. Without oversimplifying too much, generally, the bigger the structure, the longer it was active, and the deeper it goes, the better that is from the point of view of making mineral deposits. We're sitting where there was historically an ocean, effectively the Pacific coast. So sediments were being shed off the coast of North America, and a large carbonate flat platform was forming in the ocean. Think of a modern-day reef. While that was happening, lead and zinc mineralization was being deposited into the sediments, and particularly into the carbonate units, using those big faults that I just spoke about as a pathway to direct the mineralizing fluids upwards. This area represents the collision zone between what was the ancestral North American continent and terrains that accreted from the west. About 300 million years after the lead-zinc mineralization was forming in the carbonates, the Quesnel terrain was shoved in from the west and it docked onto the existing landmass. You can imagine that as that happened, there was a lot of deformation. So the sediments got crumpled and folded and crushed during accretion. And that deformation zone extends all the way from Mexico to the Yukon. In our area, that belt of rocks is what's referred to as the Kootenay Arc. In southern British Columbia, where Margaux project sits, we're sitting right over top of one of those deep crustal scale faults within this highly deformed belt of rocks. And that's a good place to be. What makes it even better is that there's 3 different ages of intrusions that have come into the older rocks. Those rocks are molten magma when they're in place. So from the point of view of mineralization, they act like heat engines. They cook up the rocks that they intrude, they introduce minerals, and then they help keep hot mineralizing fluids circulating. So one more reason why this is such a well-mineralized region. Because of all this complexity, there are many different styles and ages of mineralization in the area, as well as different commodities. And some of those mineralizing events are superimposed on one another, so it can get a bit complicated. I will try and keep the story as simple as possible in this video. The bottom line is this is a highly mineralized area, one that's been neglected in terms of modern systematic exploration, and that makes it a good opportunity for us. Just about this time last year, Margaux acquired the Sheep Creek Gold District. 2017 was our first field season on that project. It was also the first season on the northern part of the Kootenay Arc Lead Zinc project, where the jackpot target sits. So it was a busy year for us, going from multiple property acquisitions to compiling the historic data, ground truthing that data with early stage fieldwork, and then permitting the sites for drilling, and finally completing a drill program. We drilled a total of 6,500 meters in 2017 in 4 different parts of the property. About 2/3 of our drilling was directed at gold targets and 1/3 at zinc targets. I'll talk about the Sheep Creek Gold District first, then I'll move on to the Kootenay Arc Lead Zinc project, and then wrap up with an update on the Tungsten Tailings Initiative. Sheep Creek is an orogenic gold system. Orogenic just means that the veins formed during mountain building. In BC, almost half of the hard rock gold and most of the placer gold that's been mined has been from this style of deposit. The Sheep Creek district has almost 800,000 ounces of historical hard rock gold production, and that makes it the third largest past producing orogenic gold district in BC, after Braylorne and Barkerville. Last year, Geoscience BC did a study on orogenic gold in the province, and they showed that our Sheep Creek district is analogous to Barkerville in terms of the geological setting and the style and age of gold mineralization. So why is the mineralization in these two areas similar? Well, both Sheep Creek and Barkerville sit along that same suture zone between the accreted terrains and sediments that formed off the coast of ancestral North America. Basically, during the collision event, the rocks are compressed. They have to accommodate that shortening, so they fold and they break. The veins and the gold form late in the process, occupying fractures that have developed in the rocks. The big difference between Sheep Creek and Barkerville is the amount of exploration work that's been done. Over the past few years, there's been a lot of work at Barkerville. In 2017 alone, they did 157,000 meters of drilling, and that work has been very successful for them in terms of discovering new areas of mineralization. In contrast, Sheep Creek's been largely neglected since mining ceased in the early 1950s. We drilled 4,000 meters there in 2017, so it's still early days, but we believe this is an area that has very good potential and that Barkerville is a model we can use to guide our exploration. Margaux consolidated the claims in this area for the first time ever, so we now control about 95% of the district by area, with claims spanning a 10-kilometer strike length. As I said, we're simplifying our messaging, so we're now including what we used to refer to as the Bayonne and Ore Hill properties as part of the Sheep Creek Gold District, since they represent the same style of veining and gold mineralization. The historical production wasn't from a single vein, but from a series of parallel veins that occur over a 10-kilometer strike length. A good vein produced anywhere from 80,000 to 300,000 ounces of gold, with something like 25 or 30% of that vein being ore grade. The average grade from historical production of those ore shoots was between 14 and 15 grams to the ton gold. Historical records do show a little bit of variation in average grade between veins, but the veins were operated by different companies and processed in different mills, so any grade variation may have as much to do with different mining technique and mill recovery as it does with an actual variation in grade between the veins. There is a periodicity to the veins, and that's because the rocks can only accommodate a certain amount of stress before they crack. So in any given rock type, they crack on a predictable basis. There are gaps in the known vein spacing, where we'd expect another vein to be, and we see those areas as good exploration targets. In terms of geology, the main Sheep Creek camp is underlain by a layer cake sequence of rocks. Certain rock layers are better hosts than others for veins because they're more brittle and they break better. The best unit for veining at Sheep Creek is a quartzite unit, and particularly where that quartzite is capped by a less permeable argillite, so the gold-bearing fluids are trapped in the quartzite. But remember that the rocks were folded in response to the accretion event before the veins came in, so it's important to trace the favorable quartzite units through the folds. There are two main anticlines with an intervening syncline that run the length of the project. Well, the old-timers could find the veins where the favorable quartzite unit came to surface, but they had no way to trace that unit when it occurred at depth in the hinge area of one of the other folds. There is a historic resource at Sheep Creek. Our 2017 drilling wasn't designed to test that resource or to look for remnants of ore in known veins that the old-timers had left behind. In this type of deposit, it takes a lot of drilling to get to a resource stage. For our first program, we were drilling for big picture targets. We wanted to test as many different targets as possible to show that big picture potential. So where a vein had been mined in the eastern anticline, we wanted to know if it continued in that same favorable rock unit in the western anticline. Where there was a gap in the spacing of veins, we wanted to know if a vein was present there. In a couple of cases, we drilled below the historic mines to see if veining continued to depth below where the old-timers had stopped. And in 2 areas, we drilled veins that were exposed on surface, where we had high-grade gold values from rock samples, but where there was no previous drilling or historic production. And this was a very successful approach for us. We discovered several new blind veins, and we validated our exploration model. I'll quickly go through some of the different targets that we tested. We started our drilling in the easternmost part of the property, at the Maggie-Aikens target. We'd collected some rock samples from the dumps of a couple of shallow exploration pits here, and we got over 50 grams to the ton gold from surface samples. There was no previous drilling at this target and no historic production. We drilled a fan of holes from a single drill site, and in every hole we hit veining or the vein structure. The widest vein intercept was 2 meters, and the best grade we had from a vein intercept was 18 grams to the ton gold. This vein is open at depth as well as on strike in both directions. Our surface prospecting suggests that it does continue for some distance on strike, so this is an area that deserves more work. Next, we moved a few kilometers to the west to test the Bayonne vein. This was a historic producer, and we wanted to see whether the vein continued at depth below the historic mine workings. Here's a longitudinal section in the plane of the 2 veins that were mined at the Bayonne mine. There were a series of levels from surface, and then this hatched area represents stopes that were mined. Our drilling was successful at showing that both of these veins continue to depth below where mining ceased, and that the gold grade continues as well. All of our drill holes hit the vein. They were very widely spaced holes. In this section, our holes are 200 meters apart along the trace of the vein. Typically, you'd drill a vein off on a 25-meter grid pattern, and that's what we'd do if we were at the stage where we were building tons. But that wasn't the object of the exercise here. What we were trying to see was, yes or no, does the vein keep going, and are there places where the grade is comparable to what was mined? So it was encouraging to see that, yes, the vein keeps going to depth, and yes, there are good gold grades still at depth. Both these veins remain open on strike and to depth. So, another good target for further work. Next, we moved further west to the area north of Sheep Creek. Our first hole tested the Bluestone vein. This wasn't a big historic producer, but the mining never got deep enough to test the vein in the best rock unit. Our drilling was designed to drill below the old workings and target that good quartzite host rock within the core of the western anticline. We did hit a vein in the drill hole where we predicted it would be. The gold grade was low where we intersected the vein, but we know these veins only produced ore grade material for 25 or 30% of their length, so a single hole doesn't tell us about grade. It does tell us that this is a vein that deserves more drilling. Historically, one of the larger past producers in the area was the Nugget vein. It was only ever mined within the quartzite unit on the eastern anticline. We wanted to drill on strike to see whether veining existed in that same quartzite where it occurs at depth in the western anticline. Again, we hit the vein where we predicted it. We also intersected several broad zones of stockwork quartz veining with sulfides. The gold values in this hole were elevated, and so were the trace elements we want to see in the system. So this was another case where we've confirmed the big picture potential, and now we need to do more drilling to determine gold grade. The next hole targeted one of the gaps in the periodicity of the veins. This was an area where there was no historic mining or previous exploration. We hit 2 different quartz veins in this hole. They were both nice wide veins with strong sulfide mineralization, and again, gold was elevated within the vein to just about a gram to the ton. So once again, we validated this target with a single drill hole. I won't go through every single hole we drilled. There will be more information on our website if you want details, but the main point I want to leave you with is that we were drilling to test big picture potential. Are there more veins, and can we predict where they are? In 2018, we're planning to do about 9,000 meters of drilling on gold targets. We have many more brand new targets that we'll be testing. We'll also go back to some of the veins we discovered in 2017 to do additional drilling and get a better idea of the gold grade. But we do know that historically, average gold grade from mining was about 14.5 grams to the ton of gold. We also know that there wasn't a lot of variation in grade between different veins in the area, and that on any one vein, only about 25 or 30% of the vein was ore grade. so it takes close-spaced drilling to delineate these targets. We also had good success in our zinc exploration in 2017. The Kootenay Arc hosts quite a number of carbonate-hosted lead-zinc deposits, including the past-producing Jersey mine on our property and the Pend Oreille mine that Teck is currently mining in northern Washington. We drilled a few holes around the historic Jersey lead-zinc mine this past year. The lead-zinc mineralization that's been mined at Jersey is a nearly flat-lying zone within limestone. This was an underground mine, and it shut down in the early 1970s. The mineralized horizon stretches for close to 2 kilometers in one direction and about 600 meters in the other. And the higher grade portions of that horizon have been mined out. There has been quite a lot of drilling around the mine, and there is a 43-101 compliant low-grade resource here. There are some high-grade remnants left, but the potential here really seems to be for a large low-grade resource, which would potentially be open pittable, as you can see in this section. The rocks are folded here, just like they are at Sheep Creek. So what's been mined is that portion of the mineralized horizon that occurs on the near horizontal upper limb of a large fold. But mineralization could exist on the other limb of the fold also, and there's been almost no exploration to look for the continuation of that horizon. That was the target for some of our drilling in 2017. Again, as with our gold exploration, our strategy was to do work that could produce new targets and not just incrementally add a few tons to an existing resource. And that brings us to the next target. At Jersey, the limestone and the lead-zinc horizon are underlain by calcareous sediments, and the whole thing sits as one giant roof pendant above a Cretaceous intrusion. There's a large skarn system that's been developed in the calcareous rocks as a result of that intrusion, and that's the event which has introduced tungsten into the system. So the purple areas on this section are where historic tungsten mining was done, and that's where the tungsten in our tailings was derived from. But the skarn system also has gold in it, at least in some places. In 2014, Margaux was drilling for tungsten, and they intersected a skarn zone that ran 25 grams to the ton gold over 10 meters in one of the drill holes. There's a strong association between gold, bismuth, and tellurium in the skarn mineralization, and that's what you want to see in this type of deposit. And the skarn looks just like samples from Kinross's Buckhorn gold skarn in Washington. Buckhorn had about 1 million ounces of gold at a grade of about 10.5 grams to the ton, so that's a pretty attractive target. And it's a target that hasn't been well tested at Jersey and does deserve more drilling. So even though this property is part of the Kootenay Arc lead-zinc district, it does have gold potential as well. We also did some drilling in the northern part of the project at the Jackpot target. This was our first year of exploration at Jackpot, and it was very successful. It's a similar situation to Jersey, with a carbonate-hosted lead-zinc horizon that's been complexly deformed by folding. We drilled 8 holes over a 500-meter by 1 kilometer area at Jackpot, and every one of those holes hit zinc mineralization. We were expecting to see intervals of high-grade zinc, and we did. In some holes, we hit multiple mineralized horizons. Some of our better intercepts are shown here, like just about 9 meters, grading over 8% combined lead-zinc with 8.5 grams to the ton silver. What was surprising was the extent of mineralization in this area. As well as the high-grade intercepts, we hit broad zones of low-grade zinc mineralization in 7 holes, including 50 meters of 2.5% combined lead-zinc with 2.5 grams to the ton silver. That was unexpected, and since the mineralization is so close to surface, it suggests, like at Jersey, that we may not just be looking at high-grade underground scenarios. So, encouraging results, lots more drilling needed, and good zinc targets in other part of the Kootenay Arc project as well. We've covered a lot of information in this video, and I want to summarize some of the key points. This is a highly mineralized region. It's a safe jurisdiction, and it's had essentially no modern systematic exploration. Margaux consolidated the claims in the area for the first time ever. Historically, this is a region that's produced about 800,000 ounces of gold. Most of that was from Margaux' property. And there's also been significant lead, zinc, and tungsten production.
I'm Tyler Rice, President and CEO of Margaux Resources. I'm very pleased to announce today that we have submitted our application for a 10,000 ton bulk sample permit in order to follow up on our initial 3,500 kilogram lab scale sampling that we commenced on our tungsten tail pile. The primary phase has been completed and economics associated with the project are going to be concluded from the second phase of the lab scale testing, which are expected in the near future. As we move forward with this bulk sample permit, Margaux intends to further evaluate this project on a pilot scale basis with its partners, Chronomet on an operational perspective, and Streamkeepers as an environmental partner. Margaux Resources is very excited about this opportunity, not only by virtue of the environmental benefits that can be derived, but also by the potential of generating near-term cash flow for all stakeholders involved. Subject to regulatory approval and the results from the second phase lab scale testing, Margaux Resources anticipates to be in the field on a pilot scale basis for 2018.
Margaux has a strong management team. We're well funded for work in 2018 and all our drill permits are in place. Our primary focus for exploration in 2018 will be on gold. We do believe there's good upside potential for zinc mineralization on the project, and we'll continue to do the work that's needed to advance our high priority zinc targets for future drill testing.